of a lot of games that can be played on the computer. The 10 facts, by the end of first grade, your kids should know all the facts to 10. What we call efficiently or fluently. We don't mind that there's a little time. I mean, if they do 3 + 4 is 7. That's fine. I mean, I don't want to start doing this to them because that causes anxiety. But what I don't want to see is 3 + 4 is 4. Where I can tell they're still counting up in their head. They should, and if this would be a thing you could do over the summer, is practice these facts. These are fun games. They're colorful. They're not, some of them have some timing component in it, which I think is okay once they know the concept of it. But there's a variety of games here. If they don't like one, they could play another. What's best about this is that really they should play maybe 10 minutes a day, not an hour and a half on a Saturday. A little bit over time will do a lot better. And what it is by the time they get to second grade, we don't want them using their brain or their hard work to figure out 3 + 4, because they're going to be into 3-digit numbers plus 3-digit numbers. We need them thinking about the hundreds and the tens and the ones, and this should be coming easily to them. The old age flashcards, I'll tell you, as much as we love our kids, when we're the ones drilling them, it is often stressful for kids. They want to please us. They don't want to be wrong in front of us. They're going to be wrong sometimes. These games just make it fun. Some of these games have started to charge money. I don't know, I can't keep up with how quickly these things change. This one is still available, and this one, when I opened it up to try it to see, 15 minutes later, it's like, okay, Carol, you've got to shut it down. This is not what you're supposed to be doing. That is a game that I find very fun. There's a lot of repetition. If I get the 3 + 7 wrong, it does not keep track of it. It is not an adaptive one, but I'm going to see 3 + 7 multiple times over the thing. And I play it too much, even though I know my 10 facts. I would just say be a little bit careful, because there's a multiplication one that looks exactly like it. You don't want your kids on the multiplication one. I will send this through your teachers, through your newsletters, so it's electronic. So you should be able to click on the website. I don't know even if you took a picture there if it's written clear enough for you. Okay, you could probably look them up with those names and get pretty close. Okay, I'm going to start, it's 10 after. I'm Carol Little, I am the math coordinator. This will be our last meeting for the year. And I would kind of like you to notice what you do not have in front of you. I still have them. When at the beginning of the year, when we talked about adding and subtracting, and I had these out on your desks, and I was saying that kids need to be using them, it was appropriate. These would still be available, but at this point, we are getting into numbers where having the manipulatives doesn't make as much sense. It actually starts slowing them down. There are a few kids who still need these. And with those kids, I'm probably giving them smaller numbers than what most of the kids are working on. They would be working on the same concept. They would still be working on adding. But by now, today, what we're going to do is you're going to see how the kids are mostly drawing representations of what they're doing efficiently and accurately. So let's flip to the first page. Get stuff back here. And look at the vocabulary. There is not, well, there is some new. You say that this is not much new. They have just finished a unit of adding and subtracting to 40. I'm not sure if you noticed the work. We are not heavy duty on subtraction. We do some takeaway. There might be a little bit of comparison, but mostly it's about addition, and it's about understanding how addition and subtraction are related. More like 4 plus what equals 7, and how can we get there? This is not the last unit. This is the last unit with numbers in first grade, and now we're going to 100. We are not expecting them to do this with paper and pencil and numbers only. We are expecting pictures. We are expecting to see how they're figuring out, especially with regrouping. Compose and decompose is language we've used all year. Place value. A lot of this understanding that 41 plus 40, you can add the tens digits together. You don't have to do a lot of work. You can look at just the tens place. So they need to understand that place value. The number form, unit form is just how we write numbers. Make 10. That is not a mathematical term. It's called bridging 10, it's called making tens, it's called make 10, it's called make a benchmark, and it's called make a friendly number. What it is about is getting numbers so that they are easy to add. So instead of 39 plus 39, I could do 39 plus 40 and then take one away. I could do 38 plus 40. I've just taken one from one and given it to the other. But 40 is easy for me to add, especially when I understand place value. That's a beginning concept. They're going to do a lot more of that in second grade. The addition sentence, most of us would probably call that an equation. We will call it an equation also, but we will continue to call it an addition sentence like we're bilingual. We want them to understand what it means. If you remember back to your math days, there's also the term expression. Expression does not have the equal sign or an answer. So this is why this is a great term. Addition sentence is finished. It has the 3 plus, what does it say? 3 plus 8 equals. Now it can have a question mark there, and that's still a complete sentence. Place value charts we'll look at. They're still doing greater than, less than, and equal. We've seen number bonds since kindergarten. We're going to talk a lot more about that tape diagram and how it helps us. In first grade, it helps us understand the problem. It also helps us solve the problem. Quick tens. This is the one where I'm a little, I don't know if they've already started doing them or not. Okay, they have. I'm just dealing with a lot of grade levels. Quick tens honestly becomes their favorite at about this time. And then the arrow computation is really just another way of writing something down. So let's take a look. When we talk about the place value, we start having the kids understanding that they can add up by tens. So in this unit, there will be a lot of what is 10 more, what is 10 less, what is 1 more, what is 1 less. That is a very easy thing for you to do while sitting in the car. Ask them to pick a number, ask them to find a number that they see on a license plate, but only 2-digit, don't go for the whole 6 numbers. And you can be practicing that skill. What it looks like in a chart is that 10 more than 39 is what? We have 3 10s and 9 1s. I'm adding 10. I can go straight here. That is 1 more 10, so that would be 4, and the 1s stay the same. If I have 1 less than 39, this is where I'm starting. 3 10s and 9 1s. Taking away a 1, the 10s remain the same. 9 minus 1 is 8. And this is the way the work is going to come home looking. This is the way they're going to practice it. We could do it without the place value chart, but what we really want them to understand is what's happening in the place value. We could do it without it, but there would be less understanding. And that's it. Now we're moving on. Please remember, this unit is just starting. Do not go home and go to the last page of this and see if your child knows how to do it and feel like you have to teach it. It will come. We do really have several more months of school. Everybody keeps saying, oh, we're so close. Oh, yeah. Okay, addition to 100 using place value understandings. Here's our quick 10s and 1s drawing. If I have 42 plus 50, we are drawing them this quickly. I'm just representing the problem. It's a long stick and short ones. How they're dots, they might use X's. Again, it's about understanding. It's not about exactly what that looks like. So now, at the beginning, I would be having kids circle things. I have 9 10s, that's 90, plus 2 more, that equals 92. The next one, 34 plus 53. We're going to draw 34 and 53. Put all my 10s together. How many do I have? And then my 1s. Okay. I do want to talk about here, your kids are not likely to be using that crossover hatch like that. They may or they may not. It's fine to do that, but we don't tend, I would not do it as a teacher, because when we get to regrouping, that one can be hard for me to figure out where and what to do with it. If your child does it and can regroup fine, that's fine. They're just not going to see me representing it that way. Again, if your kids can draw it and understand it, I'm going to allow them to keep doing it their way, because we just want to make sure they're understanding it. There is no rule in mathematics saying we have to draw our 10s and 1s like this. So 35 and 65. And I do want to talk about hand coordination. There are kids that this circling may cause problems. I'm not going to make them. If they can keep track of it, I'm not going to make them circle. At the beginning, I'm going to show it that way, and some kids will like it. Some kids, it will become a hindrance because their fine motor skills aren't good enough. I shouldn't say it that way, but the circle may get in the way of the understanding. Okay, so would you like to add the 10s or the 1s first? Okay, I'm going to go for the 10s because you'll see what happens. I'm going to add 1, 2, 3, excuse me. This is 1 10, 2 10, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, 8 10s. I have 9 10s, and that's 90. That is something we should know. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have another 10. So this is where I would circle them, and I would make another 10. They may make the circle connected, they may not, but what we want to know is I've now represented this with another 10. I would probably mark it out. None of this is exactly, I'm just trying to show you the different ways it might be. It is the idea that they know that they got to 10 1s and they know that that equals 110. I now have 10 10s and that equals 100. I want to show you also, pretty quickly, there are going to be kids who understand. I'm going to draw 20 and 6, and I'm going to draw 50 and 8. It's really efficient to start grouping my 10s and my 1s together. It's absolutely accurate, and for kids who are seeing that relationship, it's a very strong sense, number sense. It just makes it easier now for me to add. And once I've started running across this regrouping, a lot of kids are going to start starting with the 1s. So if I've got 8 here, I need 2 to become a 10. Now I can count 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84. So as you can imagine, this is 6 weeks from now on this one. They're starting to see patterns. They're starting to know that there are more efficient ways of grouping the numbers together. They don't ever have to. I've said this before about drawing our dots. I like them drawn in that 10-frame pattern because they're so easily to understand. If kids draw them all over the place and keep track of it, I'm going to let them continue. I'll be honest, most of them who draw ones all over the place will not be able to keep track of it. Then I would have them drawing them in groups of 5s. I can look at that number there and I know it's 6 automatically. I can look at that one, I can see 2 are missing, I know it's 8 automatically. I don't have to go back and count. And our kids are to that point. They recognize numbers in the tens frame very easily. So it's a way of checking our accuracy. Okay, so that was using the drawings, very efficient. But we're going to move on to some other strategies. And these get to do a little bit more with using numbers. So we're going to decompose by place value. Are any of you mathematicians? Like anybody have a PhD in mathematics? Because you would not like what I'm going to do right now. We've talked a lot about it as a school. This symbol here in mathematics is factoring, which we wouldn't get to until 5th or 6th grade. We've decided we are doing no harm showing to them in 1st grade. But then they're just breaking their numbers apart to place value. We did have a consultant come and say, oh, you've got to stop doing that. We took a look around on Pinterest and what everybody's doing around the world. Everybody's doing it this way. I agree with not teaching kids something wrong that we then have to go reteach. Kids don't remember this by 5th grade, so I feel fine that we're not harming them. So what this is doing is I'm now breaking my number apart into place value. So this is 20 and 6. This is 40 and 2. I'm going to add my 10s together. I get 60. And some people draw the line underneath if you like. And my 1s together, and I get 8. And my answer is 68. So I hope you can appreciate that this is, we've just taken the picture completely away because our kids are understanding place value well enough that they don't need it. Okay, we may go back and forth a little bit week to week. I guarantee you that 51 plus 24 works the same. Let's move down to 69 plus 26. Why is this a more challenging problem? Yeah, we use, the term we use is we're going to have to regroup. So to begin with, we're going to write 60 plus 20 equals 80. 9 plus 6 equals 15. At the beginning, kids might want to break that apart again. And now I know it's 90 plus 5 equals 95. Pretty soon, kids are going to be able to add the 60 plus 20 mentally and just write it down. There are going to be some steps or weeks along the way where I'm going to want the child to write it down, even if they know it, because I want to make sure they really know it, and not that it wasn't luck, that they weren't looking at somebody else's paper. By the assessment, I'm not going to care. If they have turned this into mental math, that's actually what we want. That is, again, a child with number sense. We may ask them to do it 2 different ways. We will ask them to show us 2 different strategies. But they could show us 80 plus 15 equals 95, and then they could draw the quick test to show us that they understand that. And a few other ways we're going to get to in a minute. Okay, I'm going to be aware of the time. I always put more problems on here. Do we need to do another one of these? No. Okay, so that's pretty straightforward. Now we're going to get to that one that I said has multiple different names, but it really is about getting to a benchmark number that makes it easier for us. One of the bad sides of calling it 10 is that it's also 20s, 30s, it's also hundreds. So it's that idea that it's a multiple of 10. It's not just 10. Okay, 57 plus 43. Is there an easy way for me to get one of these numbers to a multiple of 10? In other words, having a 0 in the ones place. So if I want 57 plus 3, I can break this apart into 3 and 40. This becomes 60 plus 40 equals 100. Could have also done 50 plus 7, I saw that that equals 50, and I would have had 50 plus 50. And we get the same answer. And what we're doing, if I can represent this, I'm not showing you the whole problem because these numbers are too big. But it's this idea that this is our total. This problem says 5 plus 4, but I really can make it 6 plus 3 if I wanted to. I really can make it 8 plus 1 if I want to. In addition, when we have our total, we can break these apart in different ways. The reason we choose to break it apart in different ways is to make a problem easier for us. So we are always trying to find that multiple of 10. So 22 plus 38. Would you please do it by yourself? Now I want you to do it on your paper, and I want you to compare it to your partner that you're sitting with at the table. Ways this is going to work. I do want to talk about, this is a very teacher move that I put the 8 here because I was going to combine it with the 22. You could switch how you write it because it follows place value. You just don't have to circle it in a pretty way. Mathematically, it makes no difference.
Sometimes my daughter gets confused. I put this number. She said, no, this is wrong. You have to put the things here and there.
And all we can really say is, I know you've been breaking them apart by place value, and if we were talking place value, that's right. But that symbol doesn't really have a meaning, and I can break apart a number any way I want. But if she feels comfortable doing that, that's fine. You know, if that's what it is at the comfort level, because they can definitely do, let me do this in another color so we can see it. 22 plus 38, I'm going to break this apart into place value. I'm going to see that those go together, and I still have 30 plus 30. What we don't want, though, is that this doesn't mean place value. This is not a strict rule. I would say we can break it apart any way we want. If that's the way you like it, fine. Because we know that the brain likes patterns. But it's not a rule that you have to. And there's going to be 2 or 3 kids in every class that that's going to be a bit unsettling for. And so we just talk about it. They may or may not grow out of it. They may keep it by place value the rest of their life. That's fine, because it still works. Yeah. And I mean, they may be even get to the point that they may stop circling it. They will. We will move on past that. But at this point in 1st grade, they're probably going to be asked to circle. Okay, so those 2 were pretty easy. What do we do with 48 plus 23? Yeah, we're gonna break one of them apart, but not both of them. I personally would break apart. I tend to keep the bigger number. That's usually, no, I shouldn't say that. I usually pick the one with the higher ones place. I don't know the kids are going to think that through. I need 2, so that's going to leave 21 out of my number. And this is where they'll start seeing that we're not doing it completely by place value. So if I need 2, that's fine. I'm going to take 2. That leaves 21 left. I now have my 50 plus 21, and that really is starting to become mental math. It's 5 tens more. So that becomes 7 tens and 1 1. And this strategy, I can't believe they didn't teach us when we were little kids, because it makes life so much easier. It really makes a lot of addition and mental math. So here's my case, 27 plus 19. Are you cold now? So I'm going to make 19 20. As I said, it's that 9. It's the one that's closer to a friendly tens place, or a multiple of 10. So I need 1 from the 27. That leaves me with 26 and 1. I now have 20. And I can do 46. Along the way, as they're learning this, we may still see, that's fine. This is a journey in this unit. So we had decomposing by place value, and then we had decomposing to make a benchmark or friendly number. And then that's the computation. We know that the computation is fine, but real mathematics is solving real world problems. And in our case, word problems are about as real world as we need to get with first graders. So in our real world problems, we want to make sure they understand the question. Can they take the story and turn it into math? And that's what that modeling is. Can they draw us a mathematical representation of what's happening in the story? Then can they solve it? And in first grade, a lot of times that model gives them all the information to solve it. By the time we get older, by 5th grade, they won't. They'll have to do separate computation. So let's look at this. Nikki has 12 cars. Willie has 4 toy cars. When Nikki and Willie played together, how many toy cars do they have? So to begin with, I'm going to do 12 cars. Willie has 4. My tape diagram, all that means is I'm putting it into a mathematical picture. But I'm going to label it. These are cars. This is Nikki. This is Willie. I would take N and W. Most of our kids don't like that. They're still in a very concrete world and they don't like that initials thing. I'm going to offer it to them, but most of them won't take me up on it. They're going to write out the words. And then what's the question? I didn't leave myself a lot of room. I want to know how many total there are. So I have one part, another part, and my whole. This is called part, part, whole. It can be part, whole. It doesn't matter. We found out we kind of create a lot because in first grade we usually only ask them to put 2 numbers together, and they get to 3rd grade and they think they're only allowed to put 2 together. No, you can put more. We just don't ask you to at age 6. So now I have a picture of it. Now I can start solving it. If I'm clever, I can remember that I drew 12. And 1, 2, 3, 4. So that is 12 plus 4 equals what? I might do 12, 13, 14, 15, 16. I can count on. And then they need to know, did I really answer the question? I need to write, they have 16 together. They also could write, Nikki and Willie have 16 cars in all. They tend to go back, and this is really what we want them to do, and pull the language straight out of the question in the problem. That is a great way of checking that they're actually answering the problem that was being asked of them. Any questions about that? Tomorrow, I could go back and ask the kids, if I took away everything but their model, I could say, what was the question here? They should be able to look at this representation and pretty much give me the story back. So just looking at this and taking away that, they could say, oh, there were 2 kids, Nikki had 12 cars, Willie had 4 cars, and I want to know how much there is altogether. That is the point of the model.
Okay, but if they're learning place value, in order to be consistent, it wouldn't be better to put like the stick and then write it is in a place value, like what you were teaching before? Can they write the sentence like that instead of making all the dots? Put like 1 and then 2, you know, the 1 stick
Okay.
and 2.
If
Just
I
to make it
continue,
consistent,
would it
yeah.
be better that they do this?
Yeah, or
Or
write it as a place
quick
value.
diagram that you drew.
Like 10 and
10 and then 2
Oh,
dots and then-
how I drew the dots?
No, I mean,
To make it a quick
To
time,
make it-
line.
The quick 10. I would accept either. So if they had done, that'd be a lot easier, wouldn't it?
yeah.
Like that. I'm going to accept any picture that works.
I mean, I'm
Yeah,
just saying to make it consistent for what are they
So
learning.
I might get myself in a little trouble here. I want them to recognize numbers a lot of different ways. So I don't actually always want them necessarily to do it exactly the same. I would have no problem with that. Tape diagrams, strangely enough, are usually long and narrow, and I think that's why we don't do it. They're not going to be drawing dots very long. We're going to switch to the numbers. So I think right now this is just the most basic way of doing it. I would totally accept that. I would have never thought of drawing it that way for them, mostly because of the size. I know it sounds strange, but for a first grader, drawing a quick 10 and a 1 that's that small, they could quickly become confused. They could also draw the tape diagram bigger, and that would be fine. Let me do it at least accurately. Yes, I would accept it. I probably wouldn't show it that way. And I don't have a good reason why I wouldn't. I might, especially if I've got, I think most kids are going to understand it both ways. If I thought a child was struggling and that was what's going to work for them, I would definitely show it to them. Thing is we don't want to get stuck at the dots. We really want to move them on to writing the numbers. This is just going to help them to understand. The dots is just really literal. Now we're getting to the numbers. With these numbers, they then might need to come down here and draw this to solve it. They might not. And what we're showing is that if you have 12, you can now add up 1, 2, 12, 13, 14, 15, 16. But with the numbers, they can do 12, 13, 14, 15, 16. I mean, we're fine with that. So the dots, I think mostly we don't give it a lot of thought because we don't stay there very long. This is not a stage we're going to get stuck at. Yeah, I'd accept both. Okay, Tamara has 14 grapes. She ate 8 of them. How many grapes does she have left? I am going to do it not using the quick 10s, just because I don't think they're going to see it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go down here, 3, 4. She ate 8 of them. That means I need to take 8 away. So I'm just going to cross them out. So this is grapes. She had 14 and she ate 8. So this was, I don't even know how I'd say this. This is 14, 8, 8, or 14 minus 8. I can then say 1, 2, 3, 4, 5, 6 equals 6. So I can use my drawing to answer the computation. The more advanced way is going to get a little bit complicated, and this is where we probably wouldn't go, is that, wrong. This is 14, and we took away 8. Whether it's the minus 8 up there or the minus 8 down here, doesn't matter. But we're showing what we started with was the whole, and that we took away some. Now this answer is 6. Now 6 is a smaller number than 8, but we're not going to know that when we first draw the picture. A child isn't going to know. So tape diagrams are not at first, we don't worry that they're super proportional. It's an idea of representing what's going on. Does that make sense? Because I think I'm going to show you one more way of doing them. So Lee found 15 sparkly rocks. Kim found 8 sparkly rocks. How many more sparkly rocks did Lee find than Kim? And this takes an understanding. We have Lee, who found 15. We have Kim, who found 8. I want to know, what is this difference? This is where my question mark is. These are called comparisons, subtractions. We could do the other one, we could do the 8. I don't like 8 and 8, the verb and the number. We could have used this same picture up here, but kids are not a takeaway, they're not likely to. But this shows the difference between them. So 8, how many would it take to get to 15? So you might just, so I've got this is sparkly rocks. I know what my question is. What would it take? I might go 8, 9, 10, 11, 12, 13, 14, 15. It took 1, 2, 3, 4, 5, 6, 7. So 15 minus 8 equals 7. Oh, thank you. Or how we truly solved this was 8 plus what equals 15. And this is called a missing addend, and it is the way that many of us solve our subtraction problems. Actually, the story is what lends us to this. When it's a comparison, it lends us to this idea of adding up. Takeaway lends us to a subtraction problem. But pretty soon, kids are going to have that understanding that they can solve a subtraction problem one way or the other because that's the way they like to solve it. That's what makes sense to them. That's what makes easy for them. Now, I should still be writing these. This should be, how many grapes does she have left? She has 6 grapes left. And how many more rocks did Lee find? Lee found 7 more. At the beginning of the year in first grade, it would have been Lee found blank more. About mid-year, we would have taken a few words. By the end of the year, they need to be supplying the sentence on their own. So they've been seeing it all year. We've just been scaffolding it a little bit more. That make sense? Okay. So here's a question that our kids are completely capable of answering if they can follow the story. I can't read it up there. Shanika did 11 cartwheels during recess. Kim did 6 more cartwheels than Shanika. How many cartwheels did Kim do? Well, let me draw it. Shanika did 11. Kim did 6 more. Well, that means she had to have done 11 plus 6. That makes sense? And I would say most kids probably would have done this. So now we need to add to find, we want to know how many Kim got, or how many Kim did. So 11 plus 6 equals 17. Now we want to know how many they did all together. I don't need to redraw this picture. If a child did, that's fine. But now we need 11 plus 17. I'm going to break my 11 into 10 and 1. Leave that there. And now I didn't, oh, I turned this one to the friendly number. So I have 10 plus 18 equals 28. There are some students who will do 11 plus 11 plus 6. The way we laid out, or the way I laid out this problem, they probably wouldn't, but if I didn't have that question, we may have gone to how many did they do all together. A much higher level question if we didn't scaffold it with them getting this one first. So this is 11, this still equals 28. The reason I want to show you this question, the reason we have to write this statement is we could have asked either one of these questions. And soon we will be asking one or the other of these questions. By having to write this statement, we know we're answering the question that was actually asked. So I could have asked that question up here.
For grade 1, they will understand that K is 11 plus 6, or they will just add 6.
Therein lies what we're trying to teach. We have to do this close reading.
When we do for 4th grade, we did this and we had this program,
Yep.
but the kids didn't understand this one.
But if we get them drawing that model, because it doesn't say Kim did 6, it said she did 6 more than her. So
Yeah,
that
but they
this
didn't
is the
understand
whole point.
because it means 6 more.
Yep. And this is what we call close reading. This is why we go back and ask them to think about that, and that's why we ask them to draw this picture. Because as soon as they draw the picture, they can't really say she did 6. But you're right, that is the hard part of this. The 11 plus 6 is not hard for first graders. I mean, they can figure out with quick 10s or whatever. Understanding this problem. And this is about the hardest type problem they're going to get in first grade. But as you said, it continues on. Whenever we say more, yeah. And I'm going to say, my husband is a 7th grade teacher. We're not quite sure where this is coming to, but this lack of paying attention to details seems to be a wave of problems. It might be hard for first graders to understand, but 7th graders would miss this problem the same way. So it's about paying attention and paying attention to the details. It seems to be, I mean, every year, I think life changes. We could say, oh, it's due to computers and this and that. So if it is, we just still need to know how to teach it. We've had these problems all along. When calculators first came in, the big problem is they pressed the keys wrong. They knew what they were doing. So with every new generation of new devices comes new problems. Well, we can't just say, oh, the kids didn't used to have this problem. No, this is the new problem. They don't have other problems because actually they can get the right answers on the calculators. So this is the issue we're dealing with now. And I think this is a little bit of why the modeling has become so important.
What can we find this kind of word program?
Got my computer here. Okay, I can picture it. It's at, oh, they made us change our passwords. I think it's at Math Playground. It's gonna get me there. That says. Okay, and I'm sorry, I didn't ask him to set this up for me. There is a Math Playground is one of the sites that I have been giving out for years, especially if your kids are finding this very easy. The logic games in Math Playground is great. If you go to Math Playground, I don't know how I got here. I mean, I just typed it in. It comes up on my computer because I go here. But what I'm looking at is the story math. And what it's going to do, hopefully, and I'm going to go to, and then I get to choose first grade. And then it says word plus minus problems. I sure hope I'm going to the right place. Word problem set wrong. Oh, this isn't it. Okay, there's one where they actually have to set up the problems. Well, first of all, this would be fine. They're just word problems. There's another one, and I'm sure it's with them. Maybe it'll come to my head and I'll blurt it out in a minute. Where it has, it's called thinking blocks. You see? That's what I had to not think about it for a second. Where they have to build this whole, oh, it is on Math Playground. But why didn't it? Okay, I'm gonna have to put it up for you. Oh, if I just, that says videos. I will find it for you exactly. But what it does is it gives them a problem, and then it gives all these blocks kind of chunked out like this, and they have to put in, these are Kim's cartwheels, these are Shanika's cartwheels. And so they have to, they're making them understand the problem before they solve it. And I think that is probably the best thing for the kids to do. I'm just not, I can find it in video. Thinking Blocks, oh here it is, Thinking Blocks Junior. No, let's go to Thinking Blocks Edition. No. Yes. Math Playground. This is Edition, but TB is for Thinking Blocks. So here's the way the problem is it gives you the problem up at the top in purple. Then this says Radar has some gears. He uses 11 gears in a new project. He gave the remaining 33 gears to his neighbor. How many gears did Radar have less? So the first thing they have to do is how many, this says Radar's gears, total gears, neighbor's gears. So they're going to practice. Let me see, Radar gears, I'm going to put here. Total gears, because I know this part-part whole relationship. So all I've done is label the problem to begin with. And then I have to hit check. Nope, I have to hit check here. I've done something wrong, it's not letting me go. Why? I don't know what they want me to do. I don't have anything else. Nothing like doing this in front of you. I don't know. Maybe they want it this way? Well, I don't know how to solve this one. I need help.
Problem. Can you find the parts of whole? Build a model. Drag blocks and labels to the targets in the work area. The general
voice.
Ready.
So it doesn't, I'm not going to worry. Apparently I have something wrong. But the idea is it can read it to them. It is a terrible electronic voice, but if a child's having trouble reading it, they get that. But it really shows them how to set up the problem. And I don't know what to do because I really think I'm right. How else would we do it? Total gears, neighbor's gears, Radar's gears.
No, but total really goes into the grade well, not to the...
Well, I don't think they'll let me put anything in there. These are the labels. Yeah. It doesn't help that. This really makes me mad. So it would then go on, the next screen would have the same idea, but it would keep this and then it would add the numbers to it. I promise you every other time I've been able to figure it out, but today apparently I can't think like a first grader. He gave the remaining 33 years. Okay, let me, maybe that's it. Okay, really there's only so many ways I can do this. I'm not going to sit here and play with all of them. When I put this up on, before I give it to the teachers to send out for you, I will get that particular block put on the front of this, so that the teachers, when they send it out to you, you can get that website, because it is very good. I'm not a good first grade math person right now. I did realize that's not online, this would work. The thing on the very front, it gives you my address, email. It also gives the email for this sheet that I showed at the beginning. Again, when this gets sent to you electronically, you'd be able to just press on it and go. It is called, I don't know what the actual email is, or URL. You can try online addition fact practice. I'm not sure whether this would come up on such a generic title. So this is where they're going to end their numbers units this year. I do think they have one left on shapes and geometry or something at the end of the year. This is, what they're doing is very much paper pencil, but it quickly adds, as they start finding the patterns, it can move into mental math as they make those benchmark numbers. We will be sending something home at the end of the year for practicing and what you can do over the summer. We do know, especially if you're traveling, travel is actually a really great time to be practicing this stuff. I mean, these things are fun on iPads. Now, you are my first group that I've ever given anything away to. Thursday afternoon, at home, something came across my email. It's from John Orr. He does mathbeforebed.com, and he's come out with these books, and these are not particular skills. These are about thinking mathematically. And what he's done is given you a problem to ask your child. And his idea is you read with kids, right, every night before bedtime or after school, sometime. We do that practice, but we don't overly practice just math thinking. So he's starting to make these. But I can tell he's a dad. So here's the problem, but he also gives you a sheet of things you could talk to your child about. So some of these have a single right answer, some of them have many answers. But this is what I love, and this is going to be the tricky part. What you're supposed to talk about is not on the back of the question you're asking your child. Because I most likely would take this apart and hand this to the child. Well, then I can't see what I'm supposed to be talking about. So it's the page before. So if I were to go work with my child tonight, I would have this page out for the child and this page out for me. On the back of this card is the next night's thing. This is all great until you print it. I don't know if you know this. In the US, our paper is a different size than A4. So what has happened is the numbers have gotten chopped off. I didn't have time to go through and relabel each and every book. I'm going to give you these. There's one on number sense, and there is one on patterning, which is what gets into algebra. Again, I did them over the weekend. I only had so much cardstock, but I thought they were so good I kept doing them on paper. I don't know how long the paper will last, but they'll last a couple uses. If I were you, and it may take a minute, I think you want to go through and number, like it says number 9 here, and I can see barely a number 9 there. Before I took it apart, I would renumber them if I were you. But you are welcome to take one or both. There's enough that you could take both of these, but it's this idea that if we start treating math as thinking, it just becomes part of our natural routine with kids, like reading does. So you are welcome to these. They are gold and blue. I think I have plenty for everybody to take one of both if you'd like. And thank you for coming.
Thank you.